Welcome to Calculus Chat, a weekly discussion with your lecturers for 114. I'm Dr. Biggs, and here with me is Dr. Callumman.
Hello.
And Professor van der Walt.
Hi.
Wow, I think that was yet another beautifully hectic week. I'm really starting to wonder if things are ever going to calm down.
Yeah, well, I mean, it was week 5, so that's more than a third of the way through the course.
Well, at least we have a break coming sometime soon, right?
Thank goodness.
It's probably also safe to say that the hardest part of the syllabus is over.
That's a good point, right? We've been dealing with some really tricky conceptual things so far. And a lot of what we're going to be doing going forward is learning some specific machinery and how to operate that machinery to get answers. So it might get a little bit more mechanistic and less challenging with new concepts that you have to wrap your mind around.
Yes, I would say to students to take solace in the fact that since ancient times, mathematicians have been wrestling with limits.
Yes.
Yes, indeed.
If you're struggling with limits, you're not the first one.
Okay, so the biggest event last week was probably the semester test. From what I've heard, the students didn't find it easy, which I think is good. But it also wasn't ridiculously impossible, which is good. So I think we might have struck the right level to see, really, are they mastering this work?
Yes, I think there were a couple of nice conceptual questions in there, but there were also things that were more computational. So I think it was a good balance.
Yes, and the proof will be in the pudding once we get to the marking.
Speaking of marking, maybe we can, based on some of the activity on Discord today, might be a good idea to discuss the marking process.
Indeed. I mean, I think it's something that's not always so clear to students is exactly how do we go about marking a class of 800 student scripts? What are the mechanisms? How do we deal with that number?
Yes, I think the first thing is before the marking even starts, the massive logistical task of distributing the papers to 800 students. And I did a very rough calculation. I might be out by a few digits, but I worked out that the number of theoretically possible distinct semester test scripts was a 19-digit number.
Yeah, actually, I was also playing around with that, and it led me down to what's it called? The birthday problem. The birthday problem is what is the likelihood, like in a group of 10 or 20 people, that 2 people share a birthday? So a similar problem is what is the likelihood in, say, a class of 800 students that 2 of them share the same paper, given that there are so many variations?
Probably close to 0, I would think.
If that's a 19-digit number, it's going to be very close to 0.
Yeah.
Maybe with the test, it's a little higher. But then again, probably the interpretation you want as a student is not what is the chance that 2 students have the same paper, because there could be any 2. They might not know each other. What you want to know is what is the chance that one other person you know who's your friend has the same paper. And I think that chance is vanishingly small.
Yeah.
It's an epsilon.
Yeah, but I must say hats off to Dr. Biggs for designing this wonderful system we have, for generating automatically all these papers, distributing them all, and marble above marble, all of this went off without any really serious problems.
Yes, I'm actually also quite pleasantly surprised at how well it's all been going.
Dr. Biggs, maybe you could just summarize how it is done, what programming languages you use, and how you go about coming up with all of these different versions and preparing a specific version for each student with their name on it.
Sure. Okay. So, what data do we need to start with? We have the list of students which we want to create a paper for. So that's the first data set we have. The next data set is essentially the template that we have for papers. And that's for me probably the trickiest part is what we need to do to design the paper. Is usually if we design a paper, we just create here's some nice questions, put them in a paper, we're done. But now Well, we want to create for each question multiple versions of questions, right? Each one has a slighted twist or a difference. Maybe you have a greater than, the next person has a less than. Maybe you asked about this function, maybe somebody else is asked about a slightly different but similar function, right? So coming up with those variations gets quite tricky. And then to help us with building more variations, we'll often throw in some random variables. We'll say, okay, let's take a variable from some other set of numbers. And each student gets randomly assigned one of those variables. So once you do all of these things together, you very quickly, for one question, can have a tremendous amount of possibility. Then for something like an MCQ, we can also shuffle the options. We can shuffle the orders, right? To really make it difficult if you have your paper to talk to somebody else and say, hey, what do you have for A3? I have this, but, well, the question is the same. The answers are shuffled in different orders. It's going to be very hard. You have to sort of talk about, okay, that one with that picture that maybe is correlated, but maybe you're referring to another picture. It becomes a tricky to do that kind of communication. So I think it's working well for keeping our students honest.
Yeah, but I think it's not about that we suspect all of our students, are just waiting to cheat.
No,
But it's a matter of protecting the integrity of the qualification they're going to leave with once they leave the university.
exactly.
I mean, they're coming to the University of Pretoria to get a quality qualification, and a qualification without trustworthy and rigorous assessment is typically not worth much. In fact, I'd say usually less than the weight of the paper it's printed on.
Yeah, so I mean, definitely, I mean, we're doing this in the interest of our students. We want them, once they have come through 114, to be able to say, no, assessment there was very rigorous. It's almost impossible to do anything funny. I earned these marks. They are mine. So then on a slightly more technical side, right, we typeset all our questions in LaTeX. That is fairly standard for mathematicians. That's a nice way of displaying all kinds of equations. And within LaTeX, I then introduce some, extra notation, which I use Mathematica then to read the LaTeX template file. And from that, sort of read out, okay, these are the different parts of the template, these are the variables. And then it also reads in all the student numbers and does all the shuffling, right? And creates then new files, and again, LaTeX file for each student, gets then their own unique question paper and their own unique solution paper. That needs, of course, to fit with their question paper. Then I run a bit of a batch script that use some strawberry pull in the back end to actually quickly compile all of those across the 800 versions that we have. Then I rely on Python to encrypt that, to talk to a Google API, to send them via the email, and then also once we receive it, to actually go through all the submissions we get, because of course we're getting submissions from ClickUp, we're getting submissions from our Google form, we're getting submissions via email. All of these need to be reconciled, make sure, what if somebody submitted both on the Google form and via the email? How do we deal with that case? What if somebody submitted there and there, or one part there? So it's a bit of a mess. And what if somebody now didn't submit the PDF file? They submitted something else. A flag needs to come up. Something needs to be done to be dealt with. So that I've written quite a few thousand lines of code to thankfully deal with. Probably I could do it much more efficiently, but it's a bit of a job that quickly it gets the job done. I would love to have a few months that I could just make this program beautiful and make it available to other people. But at this stage, it's sort of, I would call it an experimental build, a highly experimental
Beta version.
Yes. Yeah. And I guess that's the main thing. Of course, then on the marking side, our markers, essentially, they just get one big PDF with all the scripts in. They mark the boxes, which our students will have seen, and then my program reads it again, adds up all the numbers, gives them their totals, does a lot of that administrative task actually automatically. So I'm very much positive about using this system in the future, if we even go back to paper assessment, because it's taken a lot of tasks that we usually had to do by hand or get some people to spend some hours for all 800 students adding up all their pages. I mean, this is a job that takes some time for 800 students, but it's something that can be automated and then much safer.
Yes, I'm sure listening to that, students will hopefully understand why we appeal to them to also follow instructions to not submit their PDFs upside down, to include the Section A answers on the first page of their PDF, and so on.
Yes, and I have already encountered some obscure bugs with somebody using some or other weird PDF scanner, which has the metadata in a different way, and then I can't read that data, and then it throws the whole thing off. And dealing with 800 students all doing their own thing a little bit is complicated.
Out of interest, how long does it take to actually compile 800 PDFs once you have all the other data to physically create the PDFs?
Just the compiling for 800 takes almost an hour, but what I usually do is split it in four and do it with parallel processing, and then it goes much faster. Okay, so well, that's the technical wizardry, as I call it, for how are we managing things on a technical level? Because well, we need to have some tools in order to manage all these assessments. But I think we can also talk a little bit about well, how does marking work, and not just marking in terms of well the situation we are, but in general, right?
Mm.
And a good place maybe to start is with, well, our worksheets, right? And our tutorial tests. The model for marking there is slightly different from how the semester test works. So shall we discuss that first?
Yes. So with the worksheets, our tutors help out, and they all get assigned a number of worksheets. So if there's 800 submissions and we have 8 tutors, then each one will get say 100 submissions, and he grades each one of those submissions completely.
And this is generally shuffled from week to week, so the same student won't always have their worksheet marked by the same person.
Yeah, I mean, we do follow up with our tutors. You know, we moderate their grading, and if we spot a problem, then we have a discussion.
Yeah,
You know, because we're also teaching them how to do the job better.
indeed. And well, yeah, in fact, we have a meeting every week with our tutors, right? Where we sit down and we look at, well, this is the worksheet for this week. These are the specific questions we're going to be marking in the worksheet this week. And well, let's talk about the solution, and let's talk about all the weird and wonderful ways that one can approach the solution. Because
Mm.
very often, especially as you go further in mathematics, there isn't just one correct way of doing it. There are many ways of doing it. And that is why we need qualified people to help us mark this, because you need to be able to interpret and understand, of course, what is the argument the student is making, even if they're not making it very well, in order to say, yes, this is a method that's going to work. Or, okay, there's a gap there, but if you plug that gap, then it's going to work. So, yes, you should get some marks. Or, no, this would never work because it's trying to rely on something which is wrong. And that kind of judgment it takes training and practice.
Yeah. Well, the semester test is a much higher stakes business, so that's why we as lecturers get much more actively involved there.
Indeed.
So there, instead of each marker being responsible just for a certain collection of scripts, 100 scripts or so, now each marker is responsible for a specific question across all 800 scripts. So you have perfect consistency.
Asymptotically, yes. Look, yeah, so we do pay careful attention to our grading,
Yes.
but 9 o'clock at night, 10 o'clock at night, my eyelids are getting heavy, and sometimes mistakes happen. But we do work very hard to make sure that our grading is consistent.
Something I would say to students, the burden is on the student to convince the examiner that they know what they're doing.
Yes.
So always try and present your answer on a silver platter. Make it as clear as possible, as easy to read as possible. It's a bit like insulting a person who prepares your food. It's not a very clever thing to do. And it's not in your interest to make it hard for the marker to follow your argument or to write illegibly. Make it as easy as possible to follow your argument.
Yeah, I mean, best case scenario is you want us to look at that and immediately see, this is a beautiful argument. I can follow what you're saying. You've got all your reasons here. I don't have to hunt for anything. Okay, I can see, yes, that follows from there clearly because you indicated that. Great, yes, beautiful answer.
We're also examining your presentation, your ability to express yourself mathematically.
Indeed.
So that's part of learning mathematics, is learning to communicate mathematics.
Yeah.
Learning how to express the idea that's in your head on paper or verbally. And this is something that I remember my PhD supervisor told me when I was, writing my drafts, said, you are the only one who knows what it's like in your head. Nobody else can see the thoughts in your head.
Mhm.
That's why you have to be very clear and very precise when you express your thoughts verbally or on paper.
Yes.
Yes, and when we mark, we don't just blindly mark according to the memo. We actually understand the solution. So if there were a problem in the memo, we would spot it before we mark.
Yeah, we're not computers that say, look at the page there. Is this identical to what I have there? Okay, give mark. No, in fact, most of the time, we don't even give a mark before we've read through your answer. You have to read through and see, okay, is the story you are telling making sense? Where are you starting? Where are you going? What is the tale being told? Where are the holes? Where are maybe some of the missteps? And then a picture starts forming of, okay, yes, you've missed some things. Or, wow, this is an argument that can work.
I mean, if I get a solution and I look at this and the answer at the end is not the same as what's in the memo, but I can't spot the mistake, then I go and I work out the question myself and make sure the memo is right.
Oh, yes. And I mean, it's happened to me on occasion that a student answers in such a way that I really need to go and think about it. This happened to me, it was a year or two ago in 114, that the student made an argument and it involved a pretty tricky claim. And I didn't know whether this claim was actually true or false. It involved, speaking of what we had spoken last week, the intermediate value theorem and it holding for a non-continuous function, right? That is the question, is could something have the intermediate value property even though it is not continuous? If the answer to that is yes, then maybe the student had a case that the argument might work. Now, I don't think the student had all the depth there, but I wanted to see, is this an argument that in principle could work? And it wasn't easy to verify. I spent half an hour thinking about it, looking things up to check. Actually, this is an argument that could work. It's not flawed. There is a way. I mean, sure, there are lots of details that need to be filled in, but it could work. It took me half an hour to mark that one answer.
That's commitment.
Fortunately, it doesn't usually take that long, but I think it's an illustrative case to say we do think about what you're writing, right? And we do assess it. And sometimes it isn't clear to us immediately whether it's true or false. We might have a hunch, but we hunt it down and we make sure, right? This is our skill as mathematicians, to make 100% sure, is this a workable proof? Or is there a hole? Or is there a terminal hole?
It always brings a smile to my face when I set a question where, while setting the question, I have a certain solution in mind. So I set the question with that solution in mind, and then a student comes and presents a completely different but correct argument that is actually much better than the argument that I had in mind.
Yes, although sometimes the reverse also happens, that they bring an argument which is way more complicated, but still sound. I remember we had a simple limit kind of question, and it was actually fairly easy to verify with some limit properties. But this student decided, no, they're going back to the definition, and they're proving this from scratch, and they pretty much managed to do it.
Okay.
There were one or two holes, but they got like a distinction level mark for that question.
But the course continues.
Indeed. Even though all three of us are going to be hard at work marking, the course will continue. So, well, what are we continuing on to?
Well, we finished off limits and continuity now. I had some nice things about the intermediate value theorem, limits at infinity, and then we started with differentiation.
Yes, with Dr. Kellerman, who started us off on this theme with some nice videos.
Yes, we started the definition of the derivative, and we'll carry on with differentiation rules, which are, I guess, the difference being like driving a car versus understanding what happens in the engine of the car.
Indeed, we want to see exactly how does this car function, and so we are going to be building it up from scratch. And I think we're really getting to the heart of the module now, right? Differentiation, and we're building these tools very carefully, and this beautiful machinery, in fact, that we are going to be using throughout the rest of the course.
Yes, it's really now we were getting to the meat of it. Right? We've constructed a skeleton. We've put the bones in place, and now we're going to put some meat on it. And I think it's going to turn out well. It's a nice theory.
Well, a less gruesome analogy might be we've laid the foundation and now we can start building the tower up. But hey, maybe somebody is more biologically minded.
I don't know where that came from.
I liked it.
Must be from the Star Trek Discovery I've been watching these last weeks.
I see. Now, our next theme, after we've done the differentiation, we're going to go specifically and spend weeks on applications of differentiation and some of the various wonderful things you can do with it, particularly in mathematics, to learn more about functions and various other things, but also to do things like optimization problems, which for me is one of the most beautiful applications maybe coming from 114.
This will be differentiating in one way or another for the remainder of the course.
Okay, so I'm looking forward to building that up and moving forward and getting to all this exciting, beautiful stuff. But that's going to be it for this time. Cheers.
Bye.
Goodbye.